Hello. Alright, so I think the class has started. Can you confirm, am I audible or not? Like, I think there are 2 or 3 students here right now. Yeah, cool, thanks. Okay, let's quickly do one thing. So I'm sharing my screen. Is the let's see. Is the screen visible? Like, can you see the tablet with the scribbling? Good, thanks a lot. Yeah, thanks a lot. So I think we can start in like maybe 2 minutes or something. Yeah, anyways, this is the second lecture for DP for Limited in Informatics. The aim of the series is to get like problem solving, to do some problem solving for DP problems specifically, which come in like INOI, IOI-TC, ZCO, IOI. So last time we covered 2 problems, which were, so just a recap of what we did last time. It was part 1. We discussed why we should study DP. It's like mainly because it's like 40% of the questions that are generally asked from a INOI or a ZCO perspective. Then we said what are the general guidelines that one should follow about DP. We should know the classic problems which are there in DP, and like that's like kind of a prerequisite for this lecture series, that you should be familiar with easy DP questions. Then we did problem 1 brackets, which was INOI 2016 problem. And then I think we discussed the implementation of this problem as well. Then we did 2 parts, which was INOI 2018 problem. It's the idea was to have like problems in increasing order of difficulty. Afterwards, I forgot to show you this slide which I prepared last time, which was about further readings. The idea was that all these problems are present on this, like all these good like Olympiad style problems, especially for the Indian community, like if you're aiming for INOI or something, are present on these 2 links, I would say. The first one is IRCS judge, and the second one is like the INOI practice contest, that's like always live. So this one is basically past INOI problems, I think ZCO problems also, past INOI plus ZCO. And the IRCS judge is a collection of problems that the IRCS organization made for students to be able to prepare for IOI from India. And like these problems are pretty old, so some are easy also, like IRCS judge problems, and there are a lot of them. Some are quite good. So yeah, like if you want to practice more DP problems of the flavor of Olympiad problems, then these 2 are good sources. So moving on to today's lecture. Today we'll be covering 2 more problems again. First one is training, which is from, I think it's from INOI some year, I can't remember. It's probably 2017 or something. Yeah, 2017. And the second one will be periodic strings. This is from INOI, I think 2016 or something. Probably 2016, 2015. Yeah, that's the aim for today. So yeah, let's start. Okay, so first I'll just copy paste the link of this problem on the and like you guys can go through this problem. My screen is shared so you can see me going through the problem. I'll highlight the important things. So the question basically says that Ash and his Pokemon Pikachu are going on a journey. They have to pass through n cities in the order 1 to n. Pikachu has initial strength being S initial and experience being 0. Just ignore this XV thing. It's just the, like you have 2 quantities, one is strength, the other is experience. As the Pikachu travels, like its strength or its experience may increase. And how will it increase? In each city, Ash can either choose to train the Pikachu or let it battle, but not both. The gym leader in the ith city has experience EI. If the Pikachu enters the city with strength S and trains, then his strength increases by cube of sum of his the digits of his current strength. So basically, let's say its current strength is 12. Then after training here, it will go to, like you basically sum the digits of 12, which is 1 plus 2, 3. You cube it, so that's 27. So you add 27 to 12, which is basically this thing, 12 plus 27, which comes out to be 39. So now your new strength is 39. And the second option is that you battle. If you battle, then your experience increases, and it increases by this much amount. Your current strength times the experience of the gym leader, that is your opponent of that city. And you're going in an increasing order 1 to n. You can't like pick the 5th gym leader first, then battle the first one or something. What's your objective? Your objective is to maximize the experience at the end. So that's the constraint. Now you're given n and s initially. Then you're given all the experiences of the gym leaders, and your experience is 0 at the start. So look at the constraints. N is 5000. S initial is pretty big. EI is also reasonably big. So probably we can say that complexity shouldn't have S initial from first glance. Like that's a good guess if you want to make. Yeah, and here n is less than equal to 20. here it's constant for all of them, and yeah, this is the final subtask, basically 5000 demonstrate. Alright, so firstly going through the example, yeah, let me open up my. So people who joined just now, we were going through the problem training of INOI. You can just go through you can just read the question, you'll probably understand it. I'll just go through the sample so that people are more clear about what the question says. Let me write the sample down. N is 2, S is 12, and the array is 5, 10. Yeah, so we have this, right? N is 2, S is 12, the array is 5, 10, and your experience currently, which is XV, is 0. Now if at the first gym, okay, now you have 4 options. First is to fight, second is to fight, train, third is to train, fourth is to train, fight. Let's do a poll here so that people are more familiar with it. So which of these options maximizes your eventual XV? So this one is straight train, so you can easily see that your aggregate will be 0, you won't gain any experience. In this one, you train first and then you fight. So when you train first, your 12 becomes, as we discussed earlier, 12 becomes 39, and now you fight with this guy, so that's 39 into 10, 390. What about first fight then train? When you fight first, you get 12 into 5, 60 experience, but then you train, which doesn't give you any experience. And what about the first option, which is fight? When you first fight, you gain 60 experience, then you fight the second guy also, you gain 12 into 10, that's 120, so 180. So you can see the largest value is 390, so the answer is D. Like probably one guy or two guys answered it and they answered it incorrectly, but anyhow, are people clear with the solution? You can see in the training that the answer is actually 390. Yeah. So do people understand the problem? If you have any doubts about the problem itself, like why does something happen in the problem, then just ask right now. Basically, when you train, your strength becomes strength plus SOD of strength cubed, where SOD is the sum of digits function. So that's what happens when you train. And when you fight, your experience becomes your current strength times the gym leader's experience, that is the guy you are fighting, which is EI. If you're fighting the ith guy, then this happens to your experience. Your strength remains unchanged, and in this case your experience remains unchanged. So firstly, why should one think about a DP solution here? Like why not a greedy solution? Like that's the first question. Like when people see this kind of question, that you need to be able to figure out that there is some sort of DP happening and not a greedy approach. Obviously the name of this class is DP, so you know beforehand that this is a DP question, but from a contest perspective you will not know that the question in hand is a DP question. So one way to think about it is that what's one of the greedy approaches you can think of? Maybe one greedy approach that you can think of is that I should always fight. If you always fight, then that's bad, because like it might be bad because the total amount of experience you'll get is basically initial strength times the sum of all the experiences. Correct? Any doubts here? And if you always train, I'm just denoting fight with F and train with T to keep it concise. And if you always train, then your experience will remain unchanged, although your S will become large. Like you can maximize your S a lot. That's the benefit. So one intuition might be that I should train for some time and then I should start fighting. This is like probably one of the greedy solutions that you can think of, right? That after training for some time, at this point my S will be pretty high, my strength will be pretty high, which will help me to increase this term, because here now I'll get this increase, correct? So here, can anyone tell me if I'm doing A trainings here and N minus A fights here, what's the experience going to look like eventually? So let's say after this point the strength comes out to be S prime after training A rounds. Now your experience will be something like S prime times S prime times summation E of I goes from A plus 1 to N. This is the experience of this chunk, the chunk in blue, and I'm multiplying it with the strength that I get after this point. So okay, we have a greedy solution. Does this greedy solution work? Well, no, but it does work for this subtask 2. When the strength is when the experience is constant, let's say the experience is KKK, okay, the experience is KKK for all the guys, and your initial strength is S initial. Now can you answer this question? If I am going to pick A guys to train against and remaining N minus A guys to fight against, then which order is most optimal? For this case, when all of them are same experience wise. So first option is I should train A times, and then I should fight N minus A times. Second option is I should fight N minus A times, and I should train A times. Third option is do anything, doesn't change answer. Basically do in any order, it won't affect. D, none of the above. That's the 4 options. Think that if all of them are same, and I have already decided that I'm going to train against a number of guys, and for the remaining people I'm going to fight against them, what's the optimal order of doing this? So let's put a poll. The idea of these polls is to like have a good check of whether people understand what's like intuitively. Do you understand like why do things work? Because a lot of times, like when we are problem solving, we won't go through the mathematical proof or anything. It's more about the intuition that whether it clicks or not. So it's a good feedback mechanism for me to understand like, yeah, how do you guys feel about this? Okay, so yeah, A is correct. So basically the important thing is that you can't say that the order doesn't matter. The order does matter, right? If you had trained at the very end, that wouldn't have been helpful, because even though this training increases your strength, but you don't have any fights afterwards to actually use that strength up and to gain more experience. So you should train first and then fight. So this greedy solution works for this case. So you can get like 40 points just coding this out. And coding this is easy because just iterate over all possible values of a, and for each possible value you have to calculate this expression which we were discussing, something like this, which you can do in O1 if you're smart, like if you do prefix sums and things like those. Yeah, but anyways, what's the issue with this solution when all the values are not same? So here all the values were same. Well, take an example. The first value is 100, the second value is 10, your initial strength is 5, right? Okay, let's say first is 10, second is 2. Yeah, now actually you might think that one option is fight. That's not that helpful, it will only give you 5 and 202. The other is train, that's useless, it gives you 0. Other is train fight and the other is fight train. Intuitively we might think that train fight should be good for us. Train on the first one, so 5 becomes 5 plus 5 cube, which is what, 130, right? Yeah, and then after having 130 strength, we'll use it and battle with the second guy. So 130 into 2, 260, that's our game. And but in the fourth option, fight train, we'll fight 500. Okay, and then we train, which doesn't matter, which doesn't affect us, so we get 500. So even though intuitively you might have thought that train fight is better, but actually fight train was better. Reason being that the first value was very big, so you didn't want to train that time because it was a very good opportunity to fight, because you could gain a lot of experience, right? So you can't always say that I should train at the beginning and I should fight at the end. It's a very subtle trade-off that you have to make, that sometimes I should actually train for future fights and sometimes I should fight because it's a good enough experience that I'm getting. Oh, you can't, can you see the whiteboard, Navjeet? The whiteboard that I'm scribbling on. I hope you can see that. Can anyone confirm if they can see the whiteboard? Cool. Yeah. So I was basically explaining this example 102, where train fight doesn't actually work, the greedy tactic that we were thinking of, and actual solution is fight train, where we should fight first and then train. Okay, so and when you can't think of an easy greedy strategy, then you can consider DP, that okay, maybe the solution is through dynamic programming, correct? Now, okay, one DP idea, DPIJ denotes, again, like what we covered in the last lecture, that always try to convert your DP definition in an English sentence first, then make the recurrence. So what do you need to know when you're doing DPIJ? You need to know something like, I've fought with the first I guys already, so after fighting, after covering first I elements or first I cities in this question, and currently having J strength, how much XP can I make? How much, okay, more like how much max XP can I make? Max XP can I make, right? If this was your definition, then what would be your answer? Your answer would be DP10. Option B, your answer would be DP00. Option C, your answer will be DP1 S initial. Option D, your answer will be DP0 S initial. There is lag in video. compared to my audio, is it? Okay, okay, understood. Okay, the lag is because of, okay. Okay, I'll try to write like slightly slowly or something. Yeah, because I'm not really sure from where the lag would come from. But yeah, the question was, if this is your DP, which thing will store your final answer? Like, what will you print for your final answer? If this was your definition of DP, that after covering the first I cities and currently having J strength, how much max XP can I make? Okay, people are confused or something. Interesting. I mean, nobody guessed also something. Pratham, is the issue very significantly bad or something? Like, because I have no clue. From my end, I can't really. Because nobody answered on the poll, that's why. It's manageable. Okay. Yeah, so anyways, this was the answer for this one, this question D. Reason being, you would have covered initially 0 cities. You shouldn't say that you've covered 1 city already, and your thing will be as initial, it won't be 0. Your strength will be as initial, right, at the start. So what will your recurrence look like? Well, okay, more precisely, after covering the first I minus 1 city. So actually, let's make the answer to be C actually. Yeah, let's change the definition. I think it will be easier to work with this definition, I minus 1 cities. So when you are at ith city, what can you do? You can do 2 things. You take max of both the things. Either you can train, so go to the next city with increased strength. Right? SOD denotes sum of digits. So given a number, I pass it the strength to the sum of digits function. It gives me a value, I cube it, and I add it to J. The other option is, I go to the next city, but I have actually battled at the current city. When I battled at the current city, how much experience did I gain? Option A, 0. Option B, I into J. Option B, I. So, how much experience did I gain? That's the question, right? So option A is 0. Option B is EI into J. Option C is EI into, that's it, EI. Option D is EJ into I. What term should come here? That's the question. So you're going to the next city, and this city you did a battle. This option was train option, and this option is fight option. So when you do the fight option, how much will you add to your experience? Yep, cool. So that's correct. Option is actually this one, EI times J. So when you add EI times J here, you get this thing. Right, so that's your recurrence and you're done. Now you still have to cover one more thing, which is the base case in this TP. The base case will be something like, if I'm at the n+1th city, that is, there is no city at this position, and no matter what strength I have, my answer will be 0. It doesn't give me any additional XP. Right, if I'm beyond the wall, think about what happens when you're at DPN something. You might decide to train, which is useless because training at the last city doesn't make sense. So you'll probably fight only. And when you'll fight, you'll gain some experience, which comes here, and you'll add the term dpn plus 1 something. This something and this something are same. So this term shouldn't contribute anything because you're not going to get anything, right? So that's why this is 0. So this is the base case. Okay, so we have this. So you can easily see that the transition is order 1, roughly speaking. Assume that this calculation is fast. You can calculate sum of digits of a certain number fast and then cube it fast. Then taking max over 2 options is fast. So this max operation is order 1. Now what is your DP state? DP number of cities times strength, which is your current strength. So can anyone tell me how option A order n, option B order n times s, option B order n square, option D order s square? How big is the state? That's my question. So you have one dimension which is n and you have another dimension which is strength. How slow is this process total? So well, the actual answer is n times s, not order n. It's actually n times s. Reason being that this comes out to be n and this comes out to be less than equal s, something around s. Basically you might add like some sum of digits of s each time cubed, which will increase it slightly each time, but that won't be big because you can see if your s initial strength is around 10 to the power 9, your sum of digits will at most be the number of digits in 10 to the power 9, which is like 9 times 9, because each digit is, let's say, 89. So sum of digits is at most 81, and you're cubing, so sum of digits comes out to be 81, you're cubing it, so that's roughly 10 to the power 6. So in 10 to the power 9 you're roughly adding 10 to the power 6, and you might keep on doing it n times. So your final strength will be something like 10 to the power 9 plus 10 to the power 6 times n, which is around 10 to the power 9 plus 10 to the power 6 times 5000, which is 5e9. So that's why your strength doesn't increase that much. Alright, but it's still pretty bad. I mean, strength is pretty big. We already saw in the question that strength is quite huge. So yeah, so strength can be up to 10 to the power 9. But you can do notice that this works for subtask 1 probably, because for subtask 1 you can say that if you increase a number 20 times, the strength 20 times, it won't increase that much. Like initial strength is 1, then it will become 1 plus 1 cube, which is 2, then it will become 2 plus 2 cube, which is 10, then it will become 10 plus 1 cube, which is 11, and so on. And when you do it 20 times, it won't increase that much, right? It will still be pretty bounded. So then your order n times s max will work fine. Okay, so we still don't have a solution for subtask 3, which is the last subtask, but we have some ideas. We had this DP idea, but the issue was this dimension of strength. So what I'm trying to show you guys is that this is how you'll probably approach this question, in the sense that you'll probably not get to the correct solution immediately, and IOI and like Olympiad generally has this very special thing that you have subtasks which helps you to build up the solution step by step, which ICPC doesn't have. But right now we know that we are maybe on the right track, probably on the right track, because we have something good with us. The issue is that the second aspect, the second parameter of our DP is pretty big. Now try to notice what values can the second parameter take? That's where the optimization lies for this DP. Like that's where the trick lies in this DP, I would say. If you're at DPI and your strength is currently, let's say, S initial, and you train, then your DPI and your strength becomes S initial plus something, which is what? Sum of digits of S initial cubed. Okay. And if you had fought, you would have remained at the same DP. Sorry, next city, but same strength. If from here you would have trained, then you would have gone to DPI plus 2 S initial. Let me write it like this. S initial plus sum of digits S initial cubed. Notice these two things are same. Even if you train one step or you fight and train, your resulting strength is same. Think about it like this. If your strength is S initial at the start, after some rounds, maybe you take your first training. After some rounds, maybe for the first 3 things you fight and then you train, your S initial will change to S initial plus sum of digits of S initial cubed. Then also you again fight for some time and then you train once more. It will change to S initial plus sum of digits of S initial cubed plus sum of digits of this entire thing. So S initial plus sum of digits of S initial cubed, this thing. It's pretty messy, but I hope people get the idea of what's happening. You don't have to simplify this expression. Don't think of like, how can I simplify this expression? Because this expression is pretty ugly. You won't be able to simplify this. But notice how this value is a one-to-one function. If you know the previous value, you can calculate the next value and you can keep on doing this, right? Is this clear to everyone? Just this aspect. Cool. So for notation purpose, let's use the notation S0 as the first strength that we start with. When we train, we jump to S1. When we train, we jump to S2 and so on. More formally, Si is equal to Si minus 1 plus sum of digits of Si minus 1 cubed. Agreed? So initially you are at S0. Maybe you fight, then you fight, and then you train. And after training, it becomes S1. Then you fight, then you train, it becomes S2, and so on. It keeps on. Okay, but how does that help us? Well, if you start from a certain value, S0, how many different strengths do you see eventually? So originally our DP was DPIJ, where J could range from S max to 0. It could be anywhere in this range. That's why our complexity was low. How many different values of J can actually be there? That's the question. How many different values of J are useful to us? A order n, B order S max, C order 1, D order n square. Correct. So the answer is order n, because we already saw that you're at S0. No matter when you train, even if you train after 3 rounds or you train after 5 rounds, the first time you train, you'll definitely jump to S1, no matter how many times you've fought in between. And then you fight some, and then you train the second time, and then you go to S2, and so on. So the number of different values that you will see will only be n. more exact, maybe less than n or something, but definitely not more than n. So we know that all the values of j are not actually useful to us. Only some values are useful to us. That's good for us because we know that like we don't have to calculate all j values. So we technically know intuitively that this thing ranges order n, which is I, and j also ranges order n because the useful values are only order n for us. So our total recurrence is roughly n square. But still, if you implement it this way, the issue comes that this dimension of j is pretty big. In dpij, this j can take different values, but the values themselves can be of the size 10 to the power 9. But you can't have such a big 2D array because your first array is around 5000, this is n, and your second array is around 10 to the power 9. So your total space usage is around 10 to the power 13. Which is like too big, and it will TLE and MLE both the things. Yeah, so that's bad. One way to fix it is to use maps. Maybe use unordered maps, maybe use normal maps in C++. Idea being that this dimension is useful to us, so don't create it. This dimension shouldn't be an array, this dimension should be a map. So maybe instead of declaring it like this, int dp n s max, that's one way to declare it. Don't declare it like this. Maybe consider declaring it like map int dp n. So basically then dpi will be a map which will only have order n different values, and like each will have like order n different values. The issue with that kind of thing is it's slightly slow because if you're using a map, you get a log factor whenever you're inserting or deleting things. So your total complexity might come out to be order n square log n. Or if you're using an unordered map, then it will be n square, but a slow n square because unordered maps are slow. So it won't be a fast n square. We actually want a fast n square because n is 5000. It's reasonably tight, I would say. If n was 1000, maybe this unordered map would have worked. But there is a better solution, like you can get pure n square, like fast n square. This is a slightly slow n square because you're using unordered maps. I hope people know what unordered maps are. They're basically a kind of data structure which allow you to like and look up. But that order one is like slightly slow, it's not that fast. So don't consider it like very fast. Alright, so any doubts here up to this point? That intuitively you can make it n square log n right now. Basically, this n square log n solution idea should be clear. So well, the final thing is, we already got the broad idea that we only have few distinct values that are useful to us, and they go in the manner S0, then S1, then S2, and then Sn. So let's change our definition of dp. This might have struck to some people. Instead of saying, basically say after first I cities, I'm changing my definition slightly, and being on strength Sj. Basically don't say that your strength is j. Don't say j denotes your strength. No, j will denote your strength level in this definition, S0, S1, that's how we define it. So basically what this means is you have trained j times. So if you store dpij as I being which city you are on and j being how many times have you trained. If you know you have trained 5 times, let's say you're on the 7th city and you know you have trained 5 times already, then you know for a fact that your current strength is S5 because you've trained 5 times. Each time it incremented once. So initially you were S0, then you became S1, then you became S2, then you became S3, then you became S4, and then you became S5. It happened within the first 7 cities. You don't care when it happened, but it happened. And currently you are at this strength which you want. So that's good, right? So now j can only take at most order n different values, because we showed that this sj starts from s0 and goes to sn at most, because you have only n cities, so you can train at most n times only. You can't train n plus 1 times or anything like that. So with this modified recurrence, what's our relationship? You take max of two things. Either I train, which basically means I plus 1 j plus something, or you fight, which means dpi plus 1 j, that is your strength remains the same, plus ei times what? Can you even tell me what will come at these two places? This place and this place. Okay, the first one should be easy. The first one is actually 1. Basically, when you increase your strength, originally you were at sj, now after increasing your strength you will be at sj plus 1, right after one step. And what will come here? So let's denote this entire thing as question mark, and let's do a poll so that people are just clear with what's happening. ei, that's it, ei times j, ei times sj, ei times sj plus 1. What thing should be added here? Correct. So basically you add experience at this level when you're fighting, and your strength, which is sj, right? It's not j anymore, because that was previous definition of dp. Your strength is now s of j. So that's pretty much it. Now this entire thing can be calculated in O1. Why? Because you'll have all these s's stored, so you'll calculate s0, s1, so on up to sn in like pre-computation, and then your transition will be order 1. The number of cities is order n. The number of different values that the number of like j can take is also order n, we just showed. So total algorithm is n square, time wise and space wise. Space wise because that's how much space you're using, like n into n, and time wise because that's all the values that you calculate in worst case, and each value calculation takes order 1. Any doubts in this question? Like from a idea point of view, we'll go through the implementation just now. If you have any doubts, just put them on the message box or something. Okay, so let's go through the implementation. So I'll keep on looking at the chat in between if someone has doubts. I hope everyone can see the font and everything. Just let me know in the chat if something is not visible or something. The font size is too small or anything else. So the first line was n and s. Right, so maybe we get these. Then maybe we want to compute the s array. So let's just say we have this and we compute s0. Now we try to calculate all the n values. So what is it? Si is equal to si minus 1 plus sod si minus 1 cubed. So let's actually do this. In tmp is equal to sod si minus 1. I'm just getting the sum of digits and then like just manually cubing it here. I mean it's slow slightly, but yeah, who cares? It's just cubing, so it doesn't, like, you don't have to call the power function if you don't want to. Okay, now we don't have the SOD function right now. So given a number x, what is the sum of its digits? Result is equal to 0. I keep on extracting the digits and adding them in. So what I'm doing here is I'm taking the unit digit x mod 10, adding it to the result, dividing x by 10, and keep on doing it repetitively till the time x is non-zero. This basically means this, and then returning the result. So this is our sum of digits function. So we have our S array created. We also get in the input the experience array. Okay. One thing to note here is that sum of digits, so it's 1e9 initially, and our calculation showed us that it can go to up to 5e9, something around that. 5e9 is actually, so true or false? Can you store 5e9 in an integer? True, false? Like when you're doing questions like these, you should have an idea of what's the upper bound of an integer, how big can the value be? Any clue? Any ideas? Can you store the number 5 in it? Okay, maybe people are not familiar with what this means, the scientific notation. It means 5 into 10 to the power 9. So basically 5 followed by 9 zeros. Can we store it in an integer in C++? Well, looks like no response. Don't know why. But anyways, the answer is false. You can't. So because you cannot, this array should be long. So this should be long, and this may be long. The sum of digits, okay, and the input you get is also long here. You get the sum. Yeah, that's pretty much it. Now coming to the DP part. So for the DP, you're basically saying solve, what did we discuss? 1, 0. Because our initial strength is S0. That's why I'm calling with 0, the second argument being 0. So I generally like to do personally memoized recursive approach for these questions, but that's a preference. If we have already calculated this value, then we'll return it. This is a very standard way of writing DP. A lot of people write it this way, so it's not really that special. And how big does our DP array look? Firstly, DP array is also long, because you're multiplying strengths with experiences, so it will just explode. The value itself will just explode, because like it will already have the strengths contribution to it. Otherwise, let's set ourselves to be, so one option is, so what are the two options? One option is go to the next city training, so your level doesn't change. Sorry, your level does change because you trained. The other option is you fight. When you fight, you go to the next city with the same level, but you gain an experience. The amount you gain is E city times S level. and you take the max option, the better choice basically. Right, and then you say return dp city s11. What about the base case? If city is equal to n+1, then we should just return 0. We don't care which level we are on. If we've exceeded all the cities, because I'm putting n+n here using the variable n here, that's why I made n global. That's a common paradigm trick that I or a lot of sometimes competitive programmers use. That is, make stuff global instead of passing it around, just so that it's easier to code. Not necessarily a good software development practice, but good from competitive programming point of view. So you can notice that the code writing part is actually generally easy for these kind of questions. Like, the code is pretty short and it was relatively simple to write. It wasn't that complicated. The samples work. We don't really have to care. The samples work. Yeah, and I set n to be 5005. Just +5 is just for like safety. Doesn't really care. Doesn't really matter. Yeah, that's pretty much it. Let's try to submit it. Any doubts regarding this question's implementation? This implementation. Let's see if it is easy or not, but like I expect it to, or maybe like we might have some integer long issues, maybe somewhere. But otherwise it looks good. Like, the recurrence is just this simple. If you have any doubts, if you don't understand any part, like how is the memoization happening, or how is the sum of digits function working, SOD function, or like any other thing, just put that in the message box, so that I know what you want to from my side to improve, like, in the understanding of the code. So generally, one of the ways that, like, one of the things that I do okay, let's take it out. Okay, cool. Looks like it worked. Yeah, it worked, and like time is pointing to it, so that's good. Yeah, so one of the things that I like to do is name all my arrays with capital letters and local variables as small letters. Also, like, use the same function name solve everywhere, or use the name dp everywhere, the same dp name. Yeah, that's like some of the things that I would recommend people to pick a common trait. Like, don't do capital letters if you don't want to. Just do something which is easy to memorize, and once you do a lot of questions with the same paradigm, let's say you say that I will always name my arrays capital A and capital B, then it helps you in your speed when you're programming, especially in contests or something, because you don't really have to think about what was the exact variable name in the question. Here, for example, I use the word city and S level. Generally, I won't use the word city and S level in my code. I used it here so that it's easier to understand for you guys. Otherwise, I might have used something like index, denoting the current index, and something like int jump, maybe how much we have jumped since the previous X level. So that's the personal choice, but like, try to stick with the same variable names here and there, so that whenever you're going through your own code, it becomes very second nature to know that what was I thinking when I created this array, what this array probably does. Because you, like, whenever I see a capital letter, I know this is an input array. This was given to me in the input somewhere, because that's how my Like that's my self-defined notation that I use. So I think it helps a lot in your speed and everything. So like that's one of the things that you can try to incorporate in your programming style. Yeah, that's pretty much it. That's the first question. Yeah, another thing that, so this is the first question. Now we'll move on to the second question. Before we move on to the second question, I wanted to just share with you guys this presentation. So yeah, there's a intermediate batch starting from 21st December. The idea is to like grow more. This PPT is basically not related to the current thing that we are teaching in this lecture, but yeah, there's a batch starting on the Unacademy platform. You guys can consider joining it. You get a CodeChef certification in this, and like the expense is like less than 90 INR per day. Like you have live interactive classes, without support and everything. This is the structure, which I think is very relevant if you're interested in it, to know that what's being actually taught. So that's there. Like there's this advanced GP, which is basically more dynamic programming techniques and like generally how to optimize stuff. The educators, you might have heard about a lot of them previously, and like all of them have very good credentials. You have teaching assistants, the standard CodeChef platform for the problems, and you have subscription plans. Yeah, in case you're interested. That's pretty much it. I would say like it's a good investment if you're looking to do competitive programming or contests, or I don't know, look for jobs or something. Given the fact that finding free resources is very hard sometimes. Yeah. So moving on, we have the second question. So any doubts regarding the first question, if you have, please put them on the message box. Yeah, like I have no other way of knowing if you have any doubt. And like the aim of the lecture is to teach people, which only happens like, yeah, if you specify you have a doubt, I can help you clear it. Otherwise it defeats the purpose of the lecture. Anyways, second question, periodic strings. So let's go through the question first. A string is a non-empty sequence of zeros and 1, so it should be a binary string. The length is the number of symbols in it. If u and v are strings, then uv is the concatenation. Makes sense? This is just defining what strings are in this question. Now this is the important definition of this question. A string is considered periodic if you can write it like this. That is, this string w is periodic because it can be written as concatenation of some other string multiple times. So n has to be greater equal to, you can't just put the same string again. W equal w doesn't make sense. So n has to be greater equal to. So example, this is periodic. Why? Because 110 repeats itself. 110 and then 110. So what's the question? Given a positive integer n, find the number of strings of length n which are not periodic. So notice the question doesn't ask you for periodic strings, it asks you for not periodic. Obviously, if you know one of them, calculating the other one is easy, as we will see later. Yeah, your answer should be modulo m. Non-periodic strings of length 2, this is just examples, 1, 0 and 0, 1. Non-periodic strings of length 3 are these. You don't care about what those strings are precisely, you care more about how many strings are there. And these are the subtasks. Notice the first subtask is n is the product of two distinct primes, and the second subtask is n is the power of a prime. And then you have the max subtask, which is basically this thing. And m is some other constraint which I forgot. Okay, m was the modulo. Yeah. Okay. So we don't really care about m that much in this question, because like you'll just do modulo. Like generally you don't have any tricks or any exploits that you can make about the modulo itself. So you more like care about the n only. That's the constraint. Okay. So just to gain some understanding of people, is this string periodic according to you? One one zero one one zero one. Okay, that's correct. It's false, not periodic. Why? Because if you make it one length string and you try to repeat it, it doesn't repeat because it comes 1 but then it comes 0, which is wrong. If you make it 2 length string, it doesn't repeat because 1 1 should have been repeated by 1 1. If you make it 3 length 1 1 0 and try to repeat it, it does repeat, but then third time it doesn't repeat. If you make it 1 1 0 1, that doesn't make sense because it's a 4 length thing and the entire length is 7. Okay, another example. Is this string periodic or not? I'm just trying to gauge, like just trying to help you guys understand, like clarify, basically get clear that what is periodic, what is not periodic. Cool. Yeah, the answer is true. 4 length. Right, if you see all the 4 length pieces, this is 1011, this is 1011, this is 1011, this is 1011, this is 1011. So they repeat. Interestingly, notice even 8 length pieces repeat, but it doesn't repeat at the end. So think about this case, just for example point of view. If this was a string, then you could have said it's periodic because the 4 length things repeat. If you didn't spot it, let's say you didn't spot the 4 pattern, you might have still spotted the 8 pattern, that the 8 length things also repeat. Like, doesn't really help you in any way, but like that's one of the observations that you should make here. Okay, now just think about some patterns that you can see in this question first. If the string is of length n, okay, so this is your W and it's going to be written as v times x. So W is a binary string and it's going to be written as another binary string concatenation x times. So v x times. What property should x hold? A. Tell me the best property that you think out of these. X should be less than or equal n by 2. B. X is a factor of n. C. X is less than or equal n. D. X is a square number. Some of these properties might be false, some of these might be true. Which one do you think is the best one for us for this question? So obviously x should be less than or equal n. That's trivially true because like, yeah, x can't, like you can't concatenate more than n times to make a string of length n, correct? But this is also not useful to us. We already know that. It's pretty easy to say this. X must be a square number. This is wrong actually. This is not the property. Why? Because in this example you can see 8 was not the square number, although it could be written as like concatenation of 2 8 length strings. X should be less than or equal n by 2. This is true and this is also true, but this is again not that useful to us, and this is actually useful. Reason why x is a factor of n is pretty easy to see. Assume length of W is n. Assume length of V is alpha. Then length of W is equal to length of V times x. Correct? So n is equal to alpha times x. So x must be a factor of n because we have this equation. So that's one important thing. Okay, so we noticed something. Now let's go back to the original question, which was asking how many, question was number of non-periodic strings of length n. This can also be said as total strings of length n minus number of periodic strings of length n. Right, this is the same thing. I'm just saying take all the strings and subtract the periodic strings, the number of periodic strings. This is the same as saying I calculate all the number of non-periodic strings. Firstly, do people agree that this is true? Calculating this thing and calculating this thing are the same. I'm going to show that calculating the second thing is actually easier. So firstly, what is total number of strings? Option A, n choose n by 2, which basically says n factorial upon n by 2 factorial, n by 2 factorial. Option B, 2 to the power n. Option C, n square. Option D, n factorial. How many total strings are there of length n? Correct, 2 to the power n. I'm just saying, like, yeah, but you should just be familiar with the question. So in this expression you can replace this term by 2 to the n. I hope people get why it's 2 to the n. It's quite easy to see actually. Reason being that you have an n length string, you have n dashes. In each dash you can put a 0 or a 1 because it's a binary string. So each dash you get 2 choices and you have n such choices. So total number of choices is 2 to the n. Okay, so answer is basically, or let's say, okay, let's denote P of n be number of periodic strings of length n. Okay, and dp of n be, sorry, np of n be number of non-periodic strings of length n, same thing. Then we get this relationship that np of n that we have to calculate is 2 to the n minus p of n. So we had to calculate this, but we said that this is equal to this. This is easy to know, so we now have to figure out what's p of n. Okay, any ideas of what will p of n be? How many periodic strings are there of length n? So example, let's take examples. If n is 1, how many periodic strings are there? 0, right? Because if the string is, let's say, 1 and we have to write it as 1 again, but we can't repeat it multiple times, so we don't have any way. And if the string is 0, then also we can just write it as 0 and we can't repeat things. So when n is 1, p1 is 0, we don't have any string. What about 2? So you have 4 strings, 0 0 0 1 1 0 1 1. This is periodic because 0 repeats 0, and this is periodic because 1 repeats 1. These two are not periodic. So p of 2 is 2. What about 3? So you have 0 0 0 0 1. I'll just quickly write all them. So this is periodic, easy to see. This is periodic, easy to see. This is not periodic. 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 So p of 3 is also actually 2. What about 4? I won't draw the cases for 4. Let's just think of what will happen. If it's a 1 length string that's being repeated 4 times, then it's going to look like this. If it's a 2 length string, then it might look like this, but this is already covered. So consider this one. This is not covered. 2 length plus 2 length, or 2 length plus 2 length. This is also not covered, but this one is covered. 3 length not possible, 4 length not possible. So 4 ways. Okay, So we have some idea of what's happening. So when we are trying to calculate P of n, number of periodic strings of length n, there are some periodic strings which are of length 1 being repeated n times. There are some strings which are of length 2 being repeated n times. There are some of length maybe 4 being repeated n times. Take an example. That'll make it easier to understand. Let's say n is 36. Then, because n is 36, what are the factors of 36? 1, 2, 3, 4, 6. What else? 8 is not a factor. 10 is not a factor. 12 is a factor. 4 goes with 9, so 9 was a factor. 18 is a factor. 36 is a factor. 36 is a useless factor, we can't use that. So these are the factors that are useful to us. So notice, if you're making a string of length 36 and you're trying to make it periodic, either it repeats at length 1, or it repeats at length 2, or it repeats at length 3, or it repeats at length 4, and so on, right? But you have some overcounting issues happening. If you think about all the strings of length 1, you have 1 and 0, so you have 2 strings. So you have 2 ways, which one of them is 1 1 1 1 1 36 times, and the other one is 0 0 0 0 0 36 times. When you think of length 2, you have 0 0 0 1 1 0 1 1, but you're really not interested in this and this. Why you're not interested is because these have already come here. You don't want to overcount those ways, so you just want to do these ones. So 0 1 0 1 0 1 multiple times, basically 0 1 to the power 18. Repeat this thing 18 times, or 1 0 to the power 18. Okay. For 3 also, again, you don't have any interesting strings to think about. So you have 0 0 0 and you have 1 1 1, but both of them are boring for you. These two are boring for you because they have already been done. Which ones are interesting for you? Let's answer this. How many are new for you, which you can repeat? Option A, 8. Option B, 6. Option C, 4. Option D, 2. How many 3 length strings can you use to make this 36 length thing, which are new for you? So we already showed that 0 0 0 and 1 1 1 are not new for you. Correct, 6. So basically, excluding these two, everything is new for you. If you consider all the arrangements, I mean, you can just keep on writing all the arrangements. 0 0 is not new. 1 1 1 is not new. But think about any other arrangement. For example, 0 1 0. If you repeat 0 1 0 6 times, then it's a periodic string of length 18, which we want. Okay. So you have some sort of intuition or pattern that from each of these elements, they contribute some periodic strings to 36, but they have overlaps or they have overcounting issues. That sometimes 3 contributes something which has already been contributed by 1 or something of that sort. Correct? So we can say something like P of n is equal to contribution by the first guy, or okay, for our example, P of 36 is equal to contribution from the first guy plus some contribution from the second guy plus some contribution from the third guy plus some contribution from 4th, 6th, 9th, and so on. I'm just listing out all the factors. 18th guy. Okay, but what are these contributions? Like, these are integers, we know, but like basically we want these contributions to look disjoint, That is, if this contributes some periodic strings and this contributes some periodic strings, they should be different periodic strings, and we want to count all of them. Do you get the idea? That we want to count, each one gives us some of them and all of them should be included, and we shouldn't overcount. That is, we shouldn't count the same periodic string twice accidentally. For example, if we have this periodic string, this thing repeated 4 times, now this will be encountered repeated 9 times. This will be encountered like this. That's one way to see it, that a 4 length string repeated 9 times. Another way to see it is repeated 3 times, so that's 12 length string and repeated 3 times. Basically break this 9 into 3 and put this. So for 12 length strings also this might contribute a periodic string. It's the same string, it looks the same, both the strings look the same, but we only want to we want them to contribute once to our count. That's important, so we have to take care of that. Now realizing this is hard, like this is like a pattern thing basically. So you have P of n is equal to summation contribution I, where I is a factor of n. This is like the generalized formula I was earlier using for 36 as an example. Now if we generalize it, it looks like this, that you're just iterating over the factors and each factor is contributing something. We still don't know how much it's contributing, we still have to figure that out, but it's contributing. Okay, any guesses on what the value of Ci will be? So I'll give you some options. Ci is equal to Pi, that is the smaller one. Ci is equal to NPi. Ci is equal to Pi minus 1. Ci is not related to any of these. That's also possible. Take a good 2 minutes or something and try to think about this. This is like important. Just like think what can contributions be. Take some small example. Take the example of NB12 or something, or NB6, let's say. Take some small example and think roughly what can it be. P was number of periodic strings and P was number of non-periodic strings. Just for a reminder, number of periodic of length I, number of non-periodic of length I. Okay, good. Yeah, that's correct. So this actually comes out to be NPI, number of non-periodic strings of length I. I would say that this thing was probably the hardest in this question. The remaining parts are easy. Figuring out that this is actually true is like slightly hard, like slightly non-trivial to see. The intuition is that when you consider strings of length 1, you will consider both the strings when you consider this value here, because non-periodic strings of length 1 comprises of both the strings 1 and 0. What about length 2? Non-periodic strings by definition say that those strings are new, that is, they can't be decomposed further. You can think of non-periodic strings as those strings which can't be decomposed, that is, you can't break them more. So this one has 1 0 and 0 1. That's good. These, when repeated 18 times, and this one repeated 18 times, gives you new things. What about 3? This has all the things except 000 and 111, which is also good. all of them gives you new things. Now notice carefully, this 1 0 being repeated multiple times will never intersect or will never match, look the same with 1 0 1 being repeated 12 times. So this is also 36 length, this is also 36 length, but both of them are different. And they will be different. The reason for that is, had they been the same, let's say this 1 0 18 times looks the same as 1 0 1 12 times, then you would have a contradiction, which is, how should I explain this? Yeah, let's do this today. So this is of length 2, this is of length 3. Okay, this thing repeated some number of times and this thing repeated some number of times will match. What's the LCM of 18 and 12? 6. So when you repeat 1 0 6 times and when you repeat 1 0 1, yep, sorry, I am not explaining it correctly. Okay, yeah, I understand how to explain this. Yeah, don't care about that. Let's say 1 0 1 12 times is kind of looking like 1 0 1 1 0 1 1 0 1, so on. Now, had this string looked like this, that means we would have been able to chunk out like this, all of them looking the same, all of them looking like 1 0 1, right? If that was true, then this string wouldn't have been periodic. Sorry, wouldn't have been it wouldn't have lied in non-periodic of 3. This would imply that it doesn't lie in non-periodic 3, because we were able to rewrite it as 1 0 to the 18, so there was a periodicity. You could periodically do it. That's the reason. Yeah, so basically non-periodic strings show you new strings each time. This was 3. For 4 also you can try. For 4, let's do for 4 also. NP4, this set will look something like all the strings, so all the 2 to the power 4 strings minus which strings. So you'll remove 0 0 0, you'll remove 1 1 1. Why? Because this is periodic, this is periodic. You'll remove 1 0 1 0, you'll remove 0 1 0 1. What else? Nothing else, right? So once you remove all these strings and just take the remaining collection, that remaining collection when repeated 9 times will give you 36 length strings which are unique and periodic. So that's it. So we came out with the recurrence Pn is equal to summation I is a factor of n dp, sorry, npn. And another way to write it is, if you just want to write it more naturally, p of n is equal to, okay, just write it like this, 2 to the power n minus np of n is equal to this thing, npi, I is a factor of n. This thing can be written like this if you want to, which means np of n is equal to 2 to the n minus np of I is a factor of n. I just did some algebra, I just moved around things. I wrote this like this, we already know this, and I got a recurrence like this. That's it. That's the recurrence for this question. Okay, and this is being done under the modulo m. Keep that in mind. Yeah. Now, how slow is this? This is actually pretty fast, but sometimes people get confused that this might be slow or something. So you're calculating n different values, so that's order n, and each calculation takes you this summation. Let's assume that we can calculate this pretty fast, O1. Why? Because we can pre-calculate all the powers of 2 beforehand. 2 to the power 0, 2 to the power 1, just calculate all of them. Under this modulo m, just calculate them. But what about this summation? You have to actually go through the summation, right? And what you are summing over is all the factors of I. How many factors of I will you have? How many factors of n will you have? So question is, how many factors n has? I'm basically asking you the rough upper bound on the number of factors that n can have. Like one factor is 1 maybe, another is 2 maybe, then another is maybe n by 2, then is n, and so on. How many in worst case can you have? So the actual answer is order root n. Reason being, if you have factor 1, then it has a matching factor n. If you have factor 2, it has a matching factor n by 2. More precisely, if you have factor a, it has a matching factor n by a, right? And a into n by a makes n of this thing. Think about what value of a it should become such that these two terms look like equal. So a should be roughly equal to n by a. A should be around square root n. Correct? So basically you have pairs of the form 1 times, okay, let me give you an example to make it more clear. Let's say your number is 36. Then you have 1 times 36 as one pair, 2 times 18, 3 times 9, 4 times 6, 4 times 8, 6 times 6. Notice these are all the numbers less than equal square root 36, and the right side are all the numbers greater equal 36, square root 36. So how many numbers, like how long is this list? This list is at most of the size square root 36. And total, how many elements are there? At most 2 times square root 36. Generically, at most 2 times square root n or order root n. So that's like the total number of factors are always upper bounded by root n, order root n. It's actually 2 times square root n, but anyways. So in this question also that's true. So your net complexity will be, calculating this summation will just take you root n times in worst case. So it will be n root n, something like that. As a homework problem, you can try to see that it's actually not even this much slow. It's somewhere around n log square n, or yeah, somewhere around that. That's a homework problem. You can try it out on your own. But yeah, this is a safe upper bound. But each number actually doesn't even have root n factors. Most numbers have very less factors or something. Like the number of factors they have is of the order log square-ish something. Generally, this is not like CS, computer science fact or something, number theory fact. It's more like from a comparative programming point of view that generally you don't hit root n. Yeah, so we have roughly n root n complexity. Now, since we have time, we can cover this. There are 2 ways to implement this algorithm. One is iterative, the other is recursive. One of them will be significantly faster than the other one for this DP problem. So in the iterative way, I can show you how the code will look. It will look like for n equals 0, n equal 2 to capital N, for I, which is a factor in factors n. So let's say factors n is a list. Let's say dp, I'm just writing the rough code. dpn looks like 2 to the n, and then you do dpn minus equal dpi. That's it. That's your iterative code roughly. What about the recursive code? Solve n dp n equal to the n for I in factors n dp n minus equal dpi, return dpn, and in both cases you print what? You print dpn. So here you'll actually call solve n, capital N, and there you'll just run the script, right? Broadly speaking, that's how your higher level code will look like. Can you tell me which one is faster and which one is slower? Oh, sorry, this looks slightly different. This is not dpi, this is solve I. And you have memoization here. I didn't write the memoization part, but you can add the memoization part here. That if dpn is not equal to -1, return dpn, just like we did in the previous question. So option A, iterative, is faster. Option B, recursive, is faster. Option C, same. Option D, okay, let's not have an option D. Yeah. So which one is significantly faster? Option B. Yeah, interesting. Nice. That's good. Quite good. So why is it? Option A will actually run n root n worst case. It will run n root n because you'll go through each of these and you'll go through each of these. That's what happens in iterative. In iterative, you calculate all the things, including all the redundant things. Generally, like DP iteratively done has this flaw. But when you do this recursively, the advantage that you get is when you're solving for n and you're recursing, you're solving for factors of n. Even those will, when recurse, they'll solve factors of n only. That's the benefit. So in total, you'll only solve those guys which are factors of n. Let me give you an example. If you're solving 100, n equal 100, then you'll solve 1, 2, 5, 10. Now when you're solving 10, you'll try to solve again 2 and 5. But these are already solved, so no cost. They are already solved. When you're solving 20, you'll try to solve 10. Sorry, you'll also solve 1. You'll try to solve 1, 2, 5, 10, but they're already solved. You might try to solve 4 also. Here you'll solve 4 actually. They're already solved, so that's cheap. You don't have to solve them again. You'll solve, I don't know, 40 maybe, no, 25, 1, 5, they're already solved. And you'll solve 50, has some factors, you've already solved them, that's it. Notice that when you're solving some number n, in the recursion tree, every element will be a factor of n, no matter how deep you go in the recursion tree. That's the beauty. At the top layer, you might easily see this, that okay, obviously if I'm solving n, then these will be factors of n because my recurrence says so. My recurrence just calls on i's which are factors. That's easy. But even in the bottom layers, you'll just keep on going through the factors. And because you have memoized it, you'll only go through each factor once. So instead of spending order and time calculating dp1, dp2 up to dpn, you'll only calculate the useful values. And how many values are useful to you? The number of factors of n. which is, we showed earlier, around order square root n. So only around order square root n values are useful to you, which are the factors of n, and for each of them you take at most square root n time to calculate the value, because your recurrence here was looping on a summation. So total complexity is order n. So earlier you might have thought that, oh, this algorithm is slow, it's n root n, because n was given to you as like, I think 1e6 or something, or 1e5, but it actually like simplifies to being order n if you do it smartly, if you do it recursively. So like knowing how to do it recursively and iteratively, both of them have their own benefits. When you do recursively, you get this benefit that you can skip on useless values. But when you do it recursively has this drawback, which is not relevant for this question, but sometimes it's relevant, which is that you do a lot of function calls. From a C++ perspective, when you do so much recursion and function calls, that adds an overhead, which makes it slower. So even though you might have one algorithm order n square, another algorithm order n square, one is iterative, one is recursive, it's possible that the iterative is faster because it has less recursion calls. It's just a for loop. On compilation, it just turns out to be slightly faster. But it's also possible that it's calculating a lot more values than this one. So if the time limit is tight and the constraints are tight, then you have to think about which one do you want to do, whether you want to do it iteratively or you want to do it recursively. That becomes a decision. If the time limit is tight or the constraints are tight. In this question, they were tight, so it's easier to get AC if you do it through recursion. Any doubts in the theory aspect of this question? So we still have some time. Let's go through the implementation of this question. So let's copy this. So we get n and m. Let's use the capital variable m. We have a DP array. And our constant should be something like what's mentioned here. Right. Some of this function is not useful to you. So once we get these, what we do is, okay, so one important thing that we want to do is get all the factors, get the list of all the factors. We don't want to loop over the factors, that's slow. Like, we don't want to, we don't want to loop over the factors again and again. So let's just do this. If n mod I is 0, factors push back. So we have a list of factors of n. How much time did this take? This took order n time, so that's fast. Now we say, just call dp solve for n. I'm using Vim, so that's why I have these shortcuts of like writing fast, deleting stuff. Yeah, in case like sometimes people get curious, oh, why it's happening fast. So if you're calculating for x, yes, hi Neha Kumari, you say if dpx is not calculated already, if it's already calculated, then just use that value. Otherwise, you first use, okay, so let's also make the power 2 array. is 1. Multiply is basically a function that I code just to do multiplications. The purpose is pretty useless. Under the modulo. So basically, given a and b, it just returns the product of a and b under the modulo. Notice I have these few tricks. Here I multiplied with 1 LL, which means 1 long. So if a and b are integers, this ensures that this entire thing is typecasted to a long, then taken the modulo. And because the modulo is in integer, this entire thing is small enough to be an integer. And when it's an integer, you just assign it to the result. If the result is negative, which is possible, then you add the modulo to it and then you return. True or false? Question, let's do one just to understand, if people understand this. When done, mod 5 in C++ gives what? Does it give you -2 or +3? So basically, does it give you -2 or +3? That's the question. If you think it gives you -2, say true. If you think it gives you +3, say false. Which one do you think will happen when you do -7 mod 5 in your C++ code? You have brackets, so don't worry about the bracketing. What will such a thing give you? Will it give you -2 or will it give you +3? Okay, so that's actually wrong. It gives you -2. Because my multiplication function should work when a is less than 0 or b is less than 0, or a is greater than 0 or b is greater than equal 0. Because it should work for all values of a and b, that's why it's expected that this product a into b might be negative. And when this negative number is moduloed, it will still remain negative, although the modulo will happen, but it will still remain negative. That's like a C++ thingy, which you should remember. That does happen. In maths, you generally don't say that the thing remains negative. You generally say it becomes positive. In C++, that doesn't happen. So you need to add this line 13 explicitly, that if the result is less than 0, then you should actually add it there and then. That's the mult function. So once you have the mult function, you say pow2. So pow2 just denotes, pow2i just denotes 2 to the power I under mod n, right? And once we have this, so I just keep on like multiplying it with the previous guy to get the values correctly. Now the base case was pow2 is 2 to the power 0 is 1, and the modulo was pretty big. Yeah, the modulo is at least 2, so under the modulo it doesn't affect. What should we do next? So here for auto I in factors, if x mod I is 0, then dpx equal and dpx minus dpi. You also have add function similarly. So you get two numbers. You say add will be a plus b mod m. If the result is negative, then just add it back and return the result. Notice here what's happening. So firstly, our formula was something like this. Our formula was dpx equal to 2 to the power x minus some I being factor of x dpi. This was our formula, right? I don't want to loop over all i's from 0 to x. That will be slow. I just want to loop over its factors. So what I do is I loop over the, instead of doing this, I say loop over the factors of n. Don't loop over the factors of x but loop over the factor of n, I being factor of n, and then I say if I is also a factor of x, which it may or may not be, only then subtract dpi. If it's not, then I'm not subtracting. So basically this will only consider the factors of x, but it will loop over a shorter thing. Line 28 won't take you order x time, instead not order x, instead it is order square root n. That's helpful. So this is like important to understand that how are we. I didn't even create the factors list for all of them. I just used the factors list of n because I know x is that value, x is being calculated, and x will definitely be a factor of n, so its factors will also be a factor of n. It might be slightly confusing, but yeah, just think about it. Also all my calculations are done under the modulo. I assign a 2 to the x, but this is under the modulo because here the modulo is happening because it's a mult, and then all the additions are happening under the modulo. Even though this is a subtraction, but we have taken care of it by doing this, which might happen sometimes. Yeah, that's pretty much it. Okay, the answer was different. Interesting. Not sure entirely. Okay, for 3 our code gave answer 9. That's not possible, right? Because I feel for 3 it should have been, oh, I did a mem set, yeah. Let's print out. So I'm just debugging, putting some debug statements. Okay, so 3 gets 8. 3 has only one factor, which is 1. We should have subtracted it. Why did we add it? Okay, one thing to take care of, I didn't define my base cases, which was bad for my end. If x is 1, return 2. Why? Because dp of 1 is 2. Because dp denotes number of non-periodic strings. Non-periodic strings of length 2. Oh, sorry, of length 1. Number of non-periodic strings. So that's 2. This was a base case. Maybe this fixes. Okay, this doesn't fix things. But like, yeah. Actually, there should be 2 mod in. Let's print out what's dpi also. Okay, understood the issue. Yeah, it was a very trivial mistake. Instead of using dp variable here, I should use the solve variable, the solve function here, because it's not calculated up to now. At this point, it's not it's not guaranteed to have been calculated. So I should call the solve method. The solve method will ensure that it's calculated to the correct value, and then we can just subtract. Yeah. Six, which is correct, I think. Yeah, okay. Okay, let's see where we have debug statements. Okay, so this is our code. Yep, works. Like again, notice the implementation wasn't that tricky if you do it correctly. You just had to create a factors list, powers of 2, the mult and the add function, and the main recursive, like the solve function, the DP calculation. That was the main part. But the DP part was like pretty simple. Like in its entirety, it's not even like 7 lines of code or something. It gave wrong. Not sure why. Okay, that's very weird. I'm not immediately sure why it gave wrong, because for the last case it gave correct. I know that the idea is correct. Okay, it says that we are wrong even for the product of 2 distinct primes. Let's take an example. Let's take the example of 3 and 5, so 15. So if we try for 15 with a very big prime, with a very big mod, the answer comes out to be 32766. Okay, let's try. So the answer should be 2 to the power 15. Oh, yeah, 2 to the power 15 minus the number of periodic strings. So these are all the strings. Now we subtract periodic strings. What are periodic strings? There are 2 strings of length 1. There are 6 strings of length 3. And there are probably some strings of length 5 also. How many? I'm not sure. 32 minus 2, 30 strings maybe. Okay, I think the answer is 32730. Not sure entirely, but yeah, it looks like that's the answer. Let's see what we get here. Like, what did the different values of DP say? Okay, so 3 comes out to be 0 and 5 comes out to be 0. That's super weird. Yeah, okay, let's see. So when we are calculating x being 3, dp3, you say iterate over I, which is factors. If x is a factor of this, then you subtract this. So you should get something, right? That's cool at the very least. Let's do here. See out x power 2x, see out x I dpi. Yeah, I'm just printing out everything. Okay, so when it's 15, you get it's divided by 1 and you get 2, it's divided by 3 and you get minus 1. That's weird. Why do we get minus 1? Okay, let's put it here. One, you get 2, and then 3. Okay, so for 3, 8 is the thing, and then you see it's 2, so you should have subtracted 2 and you should have left with 6, but it somehow says this thing also. Okay, so do people understand the bug? This thing should have the condition that I should not be equal to x. Basically, dp3 should only be dependent on dp1, shouldn't be dependent on DP3 itself. Like, this factor should be smaller than x. It can't be equal to x. That's an issue. Yeah, I think that's all right. Yeah, 32730 matches with our estimation. You could have just calculated this on paper pen. I did it, yeah, mentally, but yeah. So let's just go through this once. Yeah, looks good. Okay, also for IOI, I think, or like INOI and anything, there are no penalties for wrong answers, so you can just submit like when you think you're correct. You don't have to optimize for getting no wrong answers on anything. That's what. Like if you think your solution is correct, then you should just submit. Lumped problems. Let's see. Cool. Yeah, ADCs. So yeah, so like also just notice like how I went about debugging, which is like a lot of how like people who are like who have done competitive programming a lot go about their debugging. Try to find a case where it doesn't work. For me, I was easily able to like we were just lucky that the bug was so simple. So like for 15 only it broke. When we know for that case that it doesn't work, we just printed out some statements and try to see at which statement the code goes wrong. When we figured out that this statement like gave something like made DP3 back to 0, first it was 8, we expected only a subtraction of 2 and it to become out to be 6, but it got actually subtracted, 2 got subtracted from it and 6 got subtracted from it. So we realized that some issue was happening here. Then we were able to spot that okay, we are actually using the same value again, which is not good. Like this is one of the ways like people go about debugging, which is that you shouldn't like, so sometimes beginners do this a lot, that they just spend 10 minutes or 15 minutes staring at their code. They're not running it, they're not printing out statements, they're not doing anything, they're just staring at their code hoping to find the bug by itself. For bigger codes or for more complicated codes, this strategy turns out to be that not that effective, that just staring at your code and being able to find the bug. So like one of the ways to do it is that you basically start printing out things, start trying out cases where you think it doesn't work, and when you find a case, then you just print out a lot of things, add like function calls, see where which value doesn't match or not, and you should be able to find like it's kind of like binary searching or something of that sort for the portion where your code is buggy. And once you know that there is a specific portion where you were expecting it to do something else but something other than that happened, then you just like then you kind of eyeball it or like just stare at that portion and you probably can figure it out easier, like more easily. But like yeah, that's one of the debugging tactics that people generally prefer to use. Anyways, this is all for today's lecture. Yeah, in the last one we'll probably discuss some more problems, maybe try to cover some problems from IOI-TC or something like slightly harder. But yeah, if you have any feedback regarding like the problem difficulty level that you guys want to do for the next one, then you can just put the message here right now, like INOI level, ZCO level or IOI-TC level. I don't think it's reasonable to cover IOI level problems, that might be too hard, but like yeah, out of ZCO, INOI or IOI-TC, if you have any strong preferences, just put that in the message so that I know. Alright, yeah, with this we can end the session. If you have any doubts, like just ping me here for like, I'll just wait for another minute or so if you have any doubts regarding the second part. DP bitmask is a good idea actually, we can cover that. I'll have to look or I'll have to find some problems on DP bitmask, but we can definitely cover one problem of DP bitmask. It might not be that relevant from INOI perspective, but it's very useful for IOI-TC, I would say. The training camp or like the actual number. Yeah, that's a useful technique to know. Any other doubts regarding the second question, implementation wise or yeah? Anything else? I missed this. I think these are recorded on YouTube or like I think on Unacademy also. You can just watch them later if you want to. They're definitely recorded on YouTube because it's like streamed on YouTube also. So yeah. Alright, so that's it.